Hi, so today I want to go over more rules or more cases with exponents. In particular, what happens if our exponent is a fraction and what happens if our exponent is a negative number. So here we have two examples. So we have x to the 1/2 is equal to the square root of x, and x to the negative 1 is equal 1 over x. So we're going to dive into more of what these examples mean and more rules. Okay, so here we have three example cases with negative exponents, right? So when we have a negative exponent, if we just go back and look at the rules that we wrote, we see that x to the negative 1 is simply 1 over x, right? But this is missing a little bit of information. So it'd be 1 over x to the first power, right? So what the negative does is that it takes the reciprocal of x, right? So if this was a fraction, as you can see, we have another fraction 3 over 2. We'll actually get to that. So the reciprocal of x over 1, in other words, would be 1 over x. And then we'd get rid of the negative, and then we'd have the exponent remain there as a positive. So let's look at that as an example, right? So we have 4. What is the reciprocal of 4? Or in other words, 4 over 1. Well, it'd be 1 over 4. And so that gets rid of the negative. That's what the negative does. The negative takes the reciprocal of the number of our base. And then we have to the first power right here. So 4 to the negative 1 is just going to be 1/4. Okay, now what happens if that negative exponent is a number greater than 1? Okay, so remember that the negative takes the reciprocal of our base. So the reciprocal of 3, or 3 over 1, is 1/3. And remember that our exponent now will be a positive 3. So when we evaluate this, we're going to get 1 over 27. So let's recount our steps. So we have a base 3 to the negative third power. The negative takes the reciprocal of our base, in this case 3, and our reciprocal is 1 over third. And then our exponent remains, but it becomes a positive. And it goes along with the base. It carries onwards in the denominator. And then from here, we can evaluate 3 to the third power, which will be 27. So our final answer for 3 to the negative third will be 1 over 27. Now let's look at an example where we have a fraction. Our base is a fraction now. Now let's look at an example where our base is a fraction. So we have 3 over 2 to the negative fourth power. So again, let's take care of that negative first. So our negative means that we have to take the reciprocal of our base. So what is the reciprocal of 3 over 2? Well, the reciprocal of 3 over 2 is 2 over 3. And we still have our 4. So the reason why this 4 doesn't go into the denominator, so let's actually write this out, right? So if we want to take the reciprocal of this fraction, we're saying that it's going to be 1 over 3 over 2, right? 1 over 3 over 2, and then this 4 comes down here. But remember, if we're taking 1 divided by any fraction, that's going to give us the reciprocal. So really, we can rewrite this, right? We can rewrite this form as 2 over 3 to the fourth. So now from here, we can evaluate our fraction. So 2 to the fourth and that's going to give us 16 over 81. So let's recount our steps with our base being a fraction. So here we have 3 over 2 to the negative fourth power. So our negative is, we're going to take our fraction and put it underneath a 1. And then our exponent remain. It follows our base, which is 3 over 2, but now it's a positive. This 4 becomes a positive. And now remember that anything over 1 or anything beneath 1, we can rewrite it as the reciprocal. So now 2 goes on top and 3 goes on the bottom, and this exponent remains the same, positive 4. And then from here, we can evaluate, so 2 to the fourth, so 2 to the third times 2 to the third times 2 to the third, times 2 over 3. Right, so 2 to the fourth is going to be 16, and then when you multiply all the denominators, 3 to the fourth is going to give you 81. So now let's look at what happens if our exponent is a fraction, if it's 1/2. So remember that anytime it says 1/2, it's going to mean square root. So for this example, so what is 25 to the 1/2 power? Well, in other words, that's asking what is the square root of 25? And that's going to equal 5, right? But this rule is a little bit simplified, right? There's actually a more detailed rule, which is x raised to the n over m power is going to equal to this formula right here, where m is our index and n is our exponent. So what does this mean, right? So let's look back at our original example. So x to the 1/2, right? So x to the 1/2, when we fill in our variables, when we fill in whatever n and m is for 1/2, we're going to get right there. This is going to be our 1. So remember that any number or any variable raised to the power of 1, it's going to be itself, so we can actually just erase that 1. So it's just going to be x. And when our index is 2, really we're looking for what two of the same number is going to give us x. So in other words, if our index is 2, we're finding the square root. All right, so now let's look at an example where our fraction is different. So let's say we have 8 raised to the 1/3. All right, so let's use our new formula that we have for fractional exponents. So we know that our bottom number or denominator is going to be our index. So it's going to be 3 right here. Our base is going to go inside, and this 1 is going to be our exponent. So we can rewrite this as this right here. So what this means now, we need to find 3 numbers that when we find the product of all 3 numbers, it has to equal to 8. In other words, we need to find the cube root of 8. So the cube root of 8 would be 2, because 2 times 2 times 2 times 2 would give us 8. So anytime we have something like this, this is our process of solving a fractional exponent. So if we had something like, let's say 3 to the 2/3, let's fill out our parts. So our index is going to go, our denominator is going to be our index, and our base goes inside, and our numerator is the exponent on the inside. So this can be simplified even further to this right here. And then we would evaluate whatever this is. So whatever the cube root of 3 would be our answer. What happens now if we have something like 8 to the negative 4/5, right? So now let's get this into a more manageable form, right? Instead of dealing with a fraction and a negative number in the exponent, let's start simplifying. Okay, so remember, our negative means we're going to find the reciprocal. So we're going to write 1 over 8, because that's the reciprocal of 8. And then our exponent remains the same, so we're going to have 4 over 5 as our exponent. So let me rewrite this actually so you can see it clearly. Okay, and remember that we have to use our formula to fill in the parts of a radical. So 5, our denominator is going to be our index, and then our 4 is going to be our exponent. So now that we have it in this form, you have to first evaluate whatever is inside the radical, right? So whatever 8 to the 4th is, we're going to say that it's x, right? So x for now, just because I don't have a calculator on hand, so I can't exactly solve 8 to the 4th power that quickly. We need to find one number that when you multiply it by itself 5 times gives you x, or in other words, gives you 8 to the 4th power. So let's do one more example. So let's say we have 2 to the 5/6, negative 5/6. Actually, let's make this a fraction. So let's do over 5. Great. So we have to take the reciprocal of 2 over 5, right? In other words, let me just move all of this over. Oops. Okay. Okay, so remember that anytime you have a fraction in the denominator and a 1 above it, we're just taking the reciprocal of the fraction. So our 1 over 2 over 5 is going to be simply 5 over 2. So remember that our fraction now, 1 over 2 over 5, is just going to be 5 over 2. And then our exponent is going to remain the same, 5 over 6. So now we have to fill in the parts of the radical, parts of the root. So our denominator is going to be the index, and our numerator is going to be the exponent. Right? So again, whatever 5 over 2 to the 5th power is, right? So let's say it's x. We need to find some number. When you multiply it by itself 6 times, it's going to give you x. It's going to give you 5 over 2 to the 5th power. And that's what evaluating a fractional exponent means. So if this were a simple, so if this was something like, let's just say 25 over 16 to the negative 1/2, right? Again, negative means we just take the reciprocal, so let's just skip the over 1 part or underneath 1, and let's just write the reciprocal. So we have this, and we have 1/2. So we have to take the square root of the whole fraction. And if we remember our square root rules, if we have a square root of a whole fraction, we can just take the square root of the numerator and the square root of the denominator, and that will give us 4 over 5. So remember, because 1/2 is our fraction, right? So this whole thing is going to be raised to the 1 power, and the 2 is going to be our index. So we're finding two numbers that when you multiply them together and they're the exact same number, the product is going to be 16. Or in this case, in the bottom here, it's going to be 25. And so the square root of 16 is going to be 4, and the square root of 25 is going to be 5. So I hope this helps in making fractional and negative exponents a little bit easier to solve.